All right, I'd like to say to everybody here in the room and to our online audiences, good evening, and welcome to the Johns Hopkins Applied Physics Laboratory as we celebrate 20 years of the Thermosphere, Ionosphere, Mesosphere Energetics and Dynamics mission, timed. I'll point out that we do have an audience here in lobby of Building 200 and online, but we want a chance for everybody taking part in today's event to offer messages of congratulations and well wishes to the time team. So if you happen to have the Slido app or you're online and can go to sli.do, use the event name timed 20, and we have it on the screens, to offer your messages of congratulations or get the conversation going on just what an amazing mission timed has been and continues to be. Now, on December 7th, 2001, I was in the Mission Operations Center down in Mod 6 with a Baltimore Sun reporter who we invited to come in to cover the launch behind the scenes. So as we were waiting for confirmation of separation and spacecraft condition, we got to talking about some upcoming and presumably more exciting APL missions. Now, it never entered my mind then, but that 20 years later, those missions would be long over and timed and still be marching on. Just how cool is that? What an accomplishment and what a tribute to innovation and vision. Now, this evening, we're going to hear tributes from members and friends of the time team, from APL, from NASA, and from some of our partner institutions. But before we do, I invite you to please check the screens and let's take a quick look at the accomplishments and the impact of the time mission. Great stuff. And now I'd like to introduce the first of our speakers this evening, the head of APL's Space Exploration Sector, Mike Ruskevich.
Thanks everybody for being here tonight. So I will tell you Mike's little secret about time, and that is I worked on time too. But I worked on time when it was still over at Goddard, and we were trying to put together the concepts. And at the time that we were told, well, this mission is going to be executed at APL, I was not a very happy camper. I will tell you, I'm a much happier camper tonight than I was back then. So it's very good to see you, and especially because time was such a milestone. So it's hard to imagine today what we thought about 20 plus years ago when we were putting this together, but timed was the flagship for NASA's Heliophysics Division Solar Terrestrial Probes program, the first one. It set that standard. More importantly than that, that was still in an era when it was not all that well proven that you could do big science for low budgets, and timed put that stake in the ground and planted it very firmly to show that this really could be done and that this was the right model for doing it. In a lot of ways, timed has exceeded expectations. Slated for 2 years, now we're at 20. One of my snarky friends at headquarters once said, well, that merely means the engineers wasted money making it too good. Well, no such thing. We know that these things pay off in the long run. Mission data has been used for 3,000 studies. And perhaps most importantly, if I run back the clock a long way, when I was in school, I mean, probably slates, not even books then. But the picture that you always had in the textbooks was this nice little layer cake picture of the atmosphere. And then there was this thing called space, right? And it's been over my lifetime, and especially since time has been flying, that we've gained the full appreciation for just how complex that system is. Not only the interaction between the lower reaches of space, but the upper reaches and all through atmosphere, and the variation both temporally and spatially around the globe. And it's an amazing picture, and beginning to understand that is quite amazing. So I am going to get off the stage real quickly, but this is not the end. Just remember that timed is working very, very well. Dave, I haven't seen Dave come down. He was here earlier. And we know that as long as Dave Grant is in the building, timed is still alive and well. And more importantly, though, from the science perspective, we've been through 2 solar cycles now on time, and we're now seeing the beginning of a 3rd solar cycle. So we are now starting to pick up all of that science of the long-term variability of the system, and so we still have new secrets to be revealed, and I'm excited to see about what's going to be coming. So with that, I'm going to turn the microphone over to, I think our next speaker is Nikki Fox. At least that's what my run of shows says. So she's.
Unaccustomed as I am to public speaking, I'll pull something together. Hi guys, it's always a pleasure to be here and to see so many friendly, familiar faces, even though you are masked. And if I don't recognize you, I'm sorry, I'm doing my best on eyes only. So it is such a pleasure to be here to wish happy birthday to the timed spacecraft, as Mike said, the sort of cornerstone or the trailblazer of the Solar Terrestrial Physics program at NASA headquarters. We're very proud of timed. If you actually go to AGU next week and you see my Hyperworld talk, I talk about timed as being such an incredibly important mission for us. It's 20 years old. That means we have an incredible baseline to really use as the foundation for other missions that we're going to launch. We already are seeing tremendous results from Gold and Icon, putting those, of course, with timed, making that incredible constellation. The more you have, the more science you get. It's not 2 missions, double the spacecraft. It's 2 missions like 10 times the science. So we are particularly looking forward to our new missions as well. We've had a lot of the launches in SMD this year. We didn't have any HELIO launches, but next year we hope to launch OR, the atmospheric wave experiment that will go on the ISS, again, adding to the legacy that timed has started, and then looking forward, of course, to Geospace Dynamics Constellation and Dynamic. It's a great time to be a heliophysicist, but man, it's a great time to be an ITM scientist. So we have so much coming. But again, just thanks from NASA for the incredible job that you have done as a team to keep the science flowing from this mission, to keep it going 20 years. It was definitely not over-engineered. It was engineered beautifully, perfectly. And congratulations to everyone that worked on it. And here's to the next 20 years.
Thank you, Nikki, and thank you, Mike. And now please welcome to the stage John McCormick, the timed program scientist.
Hello, I'm very thankful for the opportunity to speak to you all today. I've only been at headquarters for about a year, and so what I'd like to do is share just a little bit my perspective from my earlier life as a researcher at the Naval Research Lab. When I started at NRL about 20 years ago, it coincided with the start of an initiative to improve numerical weather prediction models and importantly, to raise up the lid of those systems. And very early on, we were told point blank, you cannot do this unless you have observations at those higher altitudes. You need observations of basic state parameters for initialization and validation of your model. And as I was thinking about it, this was about the time that time launched, and SABRE measurements in particular, providing temperatures. Over the years, my work at NRL as part of a large group really benefited from the availability of those measurements. And thinking about it now, timed really, it focused and it solved on some very fascinating problems, but it also opened up a whole new area of research and application, which is this high altitude modeling and prediction. So I'd just like to share from my point of view that timed really impacted my career in an extremely positive way. And it really had impacts, that extended beyond the original, perhaps, science objectives of the 2-year mission. And I think that's really one of the things that for me makes it really special. I'll just conclude by saying that now at headquarters, supporting the time mission, you tend to think maybe it's a little routine almost, it's going 20 years, it's chugging along. It really isn't routine. It's nothing but it's a really unique tool. It's providing insights and things we need for the science and for applications today. And I'm just really happy to be here and to be part of this celebration. And thank you very much.
Thank you, John. So now there was a lot of talk about the amazing scientific accomplishments of the time mission. So now let's hear from some of the scientists who've been using all this data over the last 2 decades. And to kick that off and get that conversation going, I'd like to introduce Sam Yee, the timed project scientist.
Thank you, Mike. I think I just want to start sharing some of my personal experience, how I got involved with timed and how I view personally how I benefit from time as a whole. And of course, all the time success today is not just single person or group of persons. I think time success coming from the engineering, from building such a fantastic spacecraft, slated for 2 years, but ended up running 20, still ongoing, still on site A. So this is a tremendous spacecraft. And of course, personally, my daughter was born in one of the science working group meetings. So I grew up together with time. In fact, we were just chatting. It's not just 20 years. At least when I first got involved was 1989, when we started to participate in science definition study. Right? Many of the scientists here are part of it. And even for some people working on Melter, starting in 1986. So more than half of my professional years working on time. And we're starting from knowing very little about the atmosphere. Now we know a lot more, like Michael just said, solar cycle, 2 solar cycles. We see the solar cycle variabilities. We actually, if you look at its highlights, we see a lot more. We see whatever happening down in the atmosphere, in the lower part, affect the upper atmosphere. Earthquake affect the ionosphere. Tsunami affect the ionosphere. Changes of CO2 affect long-term changes. All because we have good instrument, good team, and very, very capable of scientists and engineering team. Build good instruments and good spacecraft. Right? I really appreciate it. So my personal thing is, I would like to thank everybody involved, from headquarters support down to the instrument, to the team. Without the fantastic teamwork, time is not going to be one to celebrate the 20 years. And look forward to the additional few more years, another 20 to follow up. But before I introduce the team, I don't know, I would like to call out Mary Malat and Vicky Ellsberg. I think people probably don't remember those 2 people from headquarters fully support of the time mission. And Mary and Vicky sent in a letter. I would like to read it out to you. And basically, she tried to describe to us how headquarters in the background, like Michael said, started with the STP program, which is a brand new line, and then how they working vigorously try to bring the new concept of the mission development to the division. So the letter says, to us, in some ways, the birth of the time mission seemed to have happened a long time ago in a far galaxy far, far away. But having as a time program scientist and program executive, midwife the mission into reality, we would like to remind you and some of the prehistory that led to the multitudes of scientific accomplishment that will be celebrated today. TIMED was the first solar terrestrial probe, a new program for what was then the Solar Terrestrial Physics Division. Although you won't find this is official histories, the defining characteristics of the SDP mission was that they were by then current definition small mission. This was the radical idea in times when better had always been associated with bigger. And it was met by a lot of suspicion, both inside and outside of NASA. But division director at that time, George Withrow, was convinced that it was an appropriate way for the SDP division to go, and he forged a relationship between the mission management staff at Goddard Space Flight Center and APL, then produced the TIME mission, the first mission in the new line. There could have been no better choice for inaugurating the STP program, exploring the in situ region of the space we've never reached before. TIME and the TIME team have produced results that not only demonstrated the importance of the mission and also demonstrated the wisdom of their move to STP, paving the way for the many missions that followed and deepened our understanding of space. Our personal thanks to all the people who helped make TIME such a success. And Mary and Vicky send their congratulatory notes. So I would like to basically give credit and also would like to recognize the science team, especially the instrument team. So for them to say a few words. First, I would like to invite Andy Christensen, who is the PI of the Groovy instrument. Andy, to say a few words. Yeah.
Well, hello, everybody. I think this is a wonderful experience. Sam was mentioning about how long this has been going on. Let's see, I think I have 35 great grandchildren now. And so it's been a long road. Some wonderful memories. I think what I would like to say is thank you to this APL crew that have pulled this thing off, the leadership that Sam has showed, and the technical team. We got a 2-year design life, and here we are 20 years and we're still operating. That's pretty incredible. I think it attests to the intellectual achievements of those engineers and scientists that put this thing together. For me, I've been kind of remotely involved. Most of the action here has been at APL. Somehow I was put in charge. I can't remember the details for that. But I do remember that Larry Paxton and I spent many months putting together a proposal, a description of what we thought needed to go on to this mission. And we were, of course, delighted that we were selected. It's been a great experience. The scientific results. Larry, what's our publication rate now? Yeah, 1,000 publications on the Groovy instrument. I think if you look at the cost per publication and compare that to some other missions that NASA has done, this one is really a star. So I'm just glad to be here. Thank you. You're here to honor us. It's been a great experience. Thank you.
Thank you, Andy. And next, I would like to recognize and invite Larry Paxton to the podium. And he is the lead scientist and also lead in the Groovy instrument in APL.
Thank you all. So you're going to hear a lot about the scientific accomplishments of this mission, but this is really a people story. It's all about personal relationships, about the relationships we established over decades. And my buddy, Andy, Andy and I have worked together for over 30 years. I first met him when I was a postdoc at Naval Research Laboratory. So that was almost 40 years ago, not quite. So I know Andy well. So I said to Andy, hey, are you ready for comments? He goes, what? And I said, he's on the schedule. So anyway, so Andy and I, of course, this is sort of the relationship we have of trust and support. And so the story I want to say is this is just an example of how much I recognize that all of you that know me, that, recognize me, we worked together for a long time. Sometimes maybe it's just a couple of years, sometimes it's decades. And I really, truly appreciate that, because Timed, and Goovy in particular, is a story about people and what we do. And let me say one extension of that. The Timed mission is really about fundamental questions of habitability. How did the world that we live in come to be like it is? We talk about the gateway to space. Sam eloquently put it. That gateway to space is the sort of the escape valve that controls how light gases escape from the atmosphere. It shapes the planetary destiny. And what we want to understand is the habitability of our own planet and how it tells us about what's happening in other planets in our own solar system and other solar systems. But the other aspect of time, and you'll see this in the movie, we're very concerned about space weather. And that's another thing of habitability. How do we maintain and achieve a spacefaring civilization that can safely operate in space? And so that's what Timed is. That's the legacy of Timed. We built that, and now we want to move forward, Timed itself, but the new missions like Gold, Icon, GDC, and Dynamic. And we're building that future. And it's going to be built on the people here today and their efforts. So thank you all. Appreciate it.
Yep. Thank you, Larry. Now, next, I would like to recognize and invite Jim Russell to the podium, and he's the Principal Investigator Emeritus from Hampton University. Saber Principal Investigator.
Hey, thank you, Sam. It's a pleasure for me to be here and to see everybody and to shake hands with people I haven't seen for a long time. I just want to say a little bit about my feelings on this very special occasion where we remember a wonderful series of great events as we started with the day of the launch when I was sitting in a building out at Vandenberg, and Sam was in another building, and things were quiet for a while, and I was wondering what was going on, as everyone else was. And then all of a sudden, it's great, and we're receiving data and doing science. And it's just been great. This milestone, 20 years, as we all know, is significant. And it's a tribute to all the people, both the engineers and the scientists working together to make this mission the success that it has been. 30 years together and produced amazing scientific results in all the work that we've done. So many thanks are due for all those who are in the trenches, so to speak. That includes the PIs and all the teams in the trenches doing the work, producing the results. This new world that we studied literally on the edge of space was essentially unexplored when we launched. We even called it the Ionosphere because we didn't know much about it. And we couldn't, it was the rockets barely got there, and it just was no way to do it. So we learned a lot, and there were many discoveries made. So it's been exceptionally rewarding to work on this mission to resolve some of the mysteries of the Mesosphere and lower Thermosphere and uncover others we didn't even know about when we launched. We've made wonderful progress. I have had the great pleasure of working and leading the Sabre team over the last 30 years. And with this instrument, it was built and tested at the Utah State University Space Dynamics Laboratory. It is working as well today, literally, as well today, as it was the day that we launched. Tremendous achievement, tremendously stable instrument, producing wonderful science. All of us working together to produce the science. And that's the point I think I want to emphasize the most is the Time team. A highlight of my life, and I'll always look upon it with great fondness, was all of the interactions we had as a science team in our meetings on the phone with Sam leading the way and giving us the guidelines and cracking the whip to make it work. So thank you, Sam, for all that you have done. So I'll just conclude by saying that it's been wonderful. The Time team has been great to work with. It's a pleasure over these last 30 years and to see firsthand the hard work and the diligence that's made this mission the great success that it is. So thank you all very much.
Thank you, Jim. And next, I would like to invite Marty Maluzak, a SABRE principal investigator, to come aboard.
Thanks, Sam. And hi, everybody, and good evening. And I'm just going to echo what everyone else has said. It's what an honor and a privilege to be here and to be part of this from when I was a graduate student. Jim talked a little bit about the history. The way I got into this is that the LIMS experiment back in the 70s and early 80s was given a lot of results. It was just seeing the bottom of the mesosphere. It was clear there was all kinds of cool stuff there. Jim encouraged me to look into this, and NASA sent me back to graduate school to actually get a PhD in the radiative transfer that would be needed to do a mission like Timed and SABRE. And so that's how I got into it. It was really remarkable and just a right place at the right time. I've been so fortunate. Also, people were commenting about things that happened in their personal life. My daughters were born. One was born in the midst of the science definition team activity, and my second daughter was born a month before time the selection was announced. So that was a very wonderful time in my life back then. I look back on that, and then all the time in between. But what I'd really like to say, I just want to thank everyone who made the Time mission possible. And this is folks at NASA headquarters and Goddard, our stakeholders, our sponsors, and all the partner institutions, because all that hard work that was done 25 years ago and that 3-year period when the instruments were built and all the magic that occurred then to make these instruments that would last so long and give us all the science. And, you know, Jim said we used to call it the Ionosphere, but now we really understand this crucial region of the atmosphere. And it's not just an own entity unto itself. It really interacts with the whole atmosphere and governs so much of the space environment. So, and I'd also like to thank my teammates. We've been together for 30 years and just accomplished so much. It's really wonderful. But then I guess the second thing I'd like to say is just looking at the enduring legacy of the Time mission. You know, NASA has a core value of wanting to touch the future. We talk a lot about that in NASA, and Time really has done that. And not just because we've been in orbit 20 years, that's part of it. But when I look at this, Time has touched so many people over the years. Students from kindergartners to postdocs have heard about Time. Citizen scientists worldwide have worked with the Time data. And of course, a lot of professional scientists have as well. And so some of those students now who have gone on into academic careers are professors at universities now, and they're coming up for tenure. And they're going to be educating students into the future. And that's going to be another legacy for an entire generation beyond us. And I think that's really going to be the legacy of Time. This is how we've really touched the future, not just in our lifetime, in our scientific careers, but the mission is going to have this influence. It's going to outlast us and go on for another generation. And so with that, I'll just say thanks again for everything. It's been a great experience, and welcome to the next 20 years of Time. Thanks.
Thank you, Marty. And next, I would like to recognize and invite Tom Woods, who is the C principal investigator, to come forward.
Well, thanks, Sam. It's great to be here and to recognize and honor this wonderful mission with everyone here tonight. And I guess looking at the clock, I have negative 2 minutes to give my spiel, but I'll give it to you real quickly in outline form. So the first bullet is remarkable journey. It started about 30 years ago with some sounding rocket experiments to explore some of the mysteries of the solar extreme ultraviolet or EUV radiation. We didn't know a lot about the solar EUV radiation because there hasn't been many measurements, and those instruments eventually became the Solar EUV Experiment or C instrument on Time. Second bullet is amazing people. Not only the people that we worked at LASP stands for Laboratory for Atmospheric and Space Physics at the University of Colorado. About 40 engineers worked on that, as well as we had 7 original co-Is. Most of those people have retired now, but they've been amazing people to work with for all these years. Been great working with APL team and the Goddard group and all the instrument teams. It's just been a lot of amazing people and a lot of amazing results come out of this mission. The third bullet is just the significant science that we've done. As I mentioned, there wasn't a lot of measurements of the solar EUV before Timed. In fact, the scientists call that the EUV hole because there's so few measurements. I'm glad to say that Time C has filled that hole. and it's produced a 20-year climate record of what the solar radiation varies, and the time other three instruments have made a climate record of how the thermosphere and ionosphere has changed over 2 solar cycles, and we're starting our 3rd solar cycle now. Another major significant result from C is how much energy is in a flare. We didn't really know how much energy is in a flare because we didn't have a full spectral coverage of the sun spectrum in the EV where the flare energy comes out of. We now know that's 50 times more than what we thought it was before we launched time. So some really significant results from C as well as all the instruments from time. So thanks everyone that's here, that's worked on time, continue to work on time, and looking forward to 20 more years. Go time.
Go time. Next, I would like to invite Aaron to the podium. He's a tidy principal investigator.
Hello. You may notice that I am not Tim Killeen or Wib Skinner or Rick Nishueski. I took over as PI of this instrument in about January of this year. Interestingly, this is the only instrument that I haven't written papers on, tidy. And so my journey through timed is basically started with the C instrument, looking at how gravity waves propagate from the day side to the night side after flares go off, and how long they take to propagate and how much they perturb the atmosphere. And then we started looking at auroral precipitation with GUVI, and then trying to see how that changes the O to N2 ratios using GUVI once again. And then I just had a graduate student who just finished, who was looking at SABRE data, looking at how oxygen density in the mesosphere and lower thermosphere affects the radiation budget in the thermosphere, and how it affects the winds and everything, and how in the MSIS model, they actually had oxygen, neutral oxygen, backwards north to south in the mesosphere because they just didn't have the data there. But now with SABRE data, they have that data and they can actually get those densities right. And when you put it into thermosphere models, you actually get a better wind distribution. And so now we're looking at the winds in the mesosphere and lower thermosphere, and I'm hoping that we can do some really, really great science with this data. Thank you.
Thank you, Aaron. And next, I think Tomoko Matsuo, she's visiting APL, and she wasn't involved in the time project, but I would like to ask her to say a few words from the community science perspective.
Thank you. Good evening. It's great to be here celebrating 20th anniversary of Timed. So many of you here have played a vital role in this important mission. 20 years ago, when I was a graduate student, I remember the excitement of time satellite launch and the prospect of time data shedding light on the part of the atmosphere that's called the Ionosphere, which is very difficult to prove with satellites and then balloons. Thanks to timed, we are no longer so ignorant about this region of the atmosphere. Time has shown us how dynamic this region of the atmosphere with its coupling with the sun and the magnetosphere, as well as the Earth's atmosphere. Time has laid a foundation for the future of ITM research and for my own research. Remember, Time was the only IT mission for decades until the recent ICON and GOLD mission. In my own research, we assimilate timed mission data as well as ICON GOLD mission data into a space weather prediction model that extends from the ground to all the way to space. I recognize that all of this is possible thanks to the work of Timed. As Newton and others once said, we are standing on the shoulders of giants. Thanks to the dedication of the people, everyone who worked on Time, this generation of scientists can dream big. And then we can continue to, this important mission will continue to inspire not only this generation of investigators, but future generation of investigators for decades to come. Thank you very much.
Thank you, Tomoko. Before I conclude my talk, I just want to point it out. We have a poster, celebration poster. Also, there's an overview pamphlet for you to take home with. In there, you're going to see, show you some idea about how productive the time days are and how we're able to outreach international communities. At the same time, and there were some highlights appear in the Time website. Feel free to browse it. Thank you.
So I asked earlier where Dave Grant was. Dave is not able to come out and join us tonight, but he is watching us on Zoom. And he sends his warm regards and thanks to this whole team for making this happen and for everything we've done. So I'd like to, for all of us to offer up Dave Grant a round of applause for thanks for everything he's done.
Thanks again, Mike, and thank you, Sam. In fact, thanks to all of our speakers for your tributes and really for the chance for us to reflect on the work and the vision that went into building and maintaining this important mission. And I thank you all for joining us today and for continuing to ride along with Timed as it enters its third decade of operations with the promise of many more discoveries to come. So thanks again. Please enjoy the reception.